worldwide, we use 4 or 5 billion with a B tons of cement every year. And then cement is about 10% of concrete. So we use 40 to 50 billion with a B tons of concrete every year globally.
Welcome to the Fine Homebuilding Pro Talk podcast, a regular discussion with building industry professionals. Today I'm joined by Cody Finke, CEO of Brimstone Energy, a startup trying to solve the carbon problem of Portland cement. You can find the Fine Homebuilding Pro Talk podcast and the original Fine Homebuilding podcast at finehomebuilding.com/podcast. You can leave feedback and ask questions there too. Cody, thanks a million for being on the show.
Yeah, thank you, Patrick. I appreciate it.
I want to get right to it. Tell me what the heck you're doing. Tell me about your company, first of all, and what you're trying to do.
Yeah, so thanks for asking. So Brimstone Energy is trying to globally decarbonize the world of cement. So I'm going to double click on that a little bit because it's a new topic for a lot of people. So cement, or ordinary Portland cement, is the binder in concrete, right? So concrete is the building material and cement is what makes it stick together. And concrete is an interesting material. It's actually the most consumed human-made material on the planet, but it has a really large carbon impact. So almost 100% of the carbon comes from the production of cement, the cement that's in the concrete. And all told, cement is responsible for about 5.5% of greenhouse gas emissions, or 8% of CO2 emissions. So there's a few ways to say that are more impactful. So one is, if the cement industry were a country, it would be the third largest emitter after China and the United States. Another way to say it is the total emissions from cement are about the same as cars. So all passenger vehicles make up maybe 6.5% of greenhouse gas emissions. And this is 5.5%.
Is that worldwide, Cody, or in the U.S.?
That's worldwide. Uh-huh. Yeah. Thank you. And cement is, particularly interesting because it is generally seen as one of those parts of the greenhouse gas problem that's particularly difficult to decarbonize. And I shudder a little bit when I say that because it's just a different problem, I think. And it's a different problem because most of the CO2 emissions have nothing to do with energy. So we talk a lot about like cleaning up or stopping greenhouse gases by switching from a fossil fuel to clean energy like solar or something like that. But for cement, it uses energy and it typically uses fossil fuels to produce. But if we were to use 100% clean energy, 60% of the emissions from cement would still persist. And that's from this really interesting problem in that
it's chemistry, right?
That's correct. Yeah. So we make cement today from a rock called limestone, which is calcium carbonate. And when you heat up calcium carbonate, the rock itself actually decomposes into carbon dioxide and lime. So most of the CO2 emissions come from the rock. And we get rid of the CO2 in order to access the lime, calcium oxide, which is what turns into Portland cement. So now just what our company does. So what our company does is, we have a firm belief that it would take way too long to change the material. So we are still making Portland cement. There's no difference whatsoever in the cement that we make and the cement that's made via the conventional process. But the key difference in how we make it is we don't use limestone. We use different rocks that contain calcium. So namely, these are calcium silicate rocks. Probably the most household name is basalt, but it turns out that calcium silicate rocks, there's a lot of different types of them, and they're much more common than limestone, and they do not have CO2 in them. So when we extract the calcium, we don't produce the CO2.
So why isn't this mainstream if we know the process? And my guess is that it's more complicated, or you need higher temperatures or something like that, right?
Yeah, so it's a more complicated answer, so please bear with me while I do that. But this is a great question, and it's always a it's always a question, like in hindsight, we can look back at big industrial changes and, speculate about why they happened and why they didn't happen earlier. And I hope that one day we'll be able to look back at Brimstone and our process and say, okay, well, this is now the standard way that we make cement, and we can speculate about why it didn't happen earlier. But how I understand it is it's actually an economic story, and it's an economic story of that is related to the production of electricity from burning coal. So it gets a little far afield. But right now, to make cement, we actually combine, is simply put, two materials. So one is ordinary Portland cement, and that's what comes out of cement plants. And then the second material is called a supplementary cementitious material. And for simplicity's sake, supplementary cementitious materials are basically what's called Class F fly ash. So Class F fly ash is the waste product from burning coal to make electricity. So you basically collect the ash from a coal-fired power plant, and then you mix that in with ordinary Portland cement, and that combination is cement. And I won't go into why we do that in this context, but I'm happy to later. But the point is, since about 1900, the fraction of total energy supply that comes from coal has been decreasing. And it's primarily been decreasing because making electricity from coal is about 30% efficient, whereas making electricity from natural gas via combined cycle natural gas power plant is about 60% efficient. So even though per unit energy, coal is actually a bit cheaper than natural gas typically, because the power plant with natural gas is so much more efficient, we've been replacing coal-fired power plants with natural gas power plants, and now to some extent renewables as well. And what that means is the amount of fly ash that we've been producing has been decreasing relative to the amount of cement that we've been producing, which has been monotonically increasing. Right. So
to paraphrase, you need more Portland to make up the deficit of fly ash. Is that correct?
Well, no, not quite. So what has been happening is that we still need just as much fly ash, but the fly ash has just been getting more expensive because instead of, there used to be a coal-fired power plant maybe 50 miles away that you could ship fly ash in from to your cement plant or to your concrete facility, and now maybe you have to ship it in from Mexico or China or some other place. So it's got a lot more expensive because there's a lot more shipping and logistics associated with it. And we're getting to a point where there's actually going to be a global scarcity, and it turns out that how our process actually works is we co-generate both Class F fly ash, for example, and ordinary Portland cement from a single rock at a single site. So in a world that was maybe 20 years ago, where fly ash was abundant, our process maybe would make sense, but it wouldn't make that much sense because fly ash was free and next door. And now that we have replaced more coal-fired power plants and gotten cheaper electricity because of it, we need another source of fly ash, and our cogeneration process that makes both is actually a more economical way to make cement. So it's sort of that complicated economic story.
Wow. So are you capturing the carbon that would be ordinarily released when you heat
limestone?
Limestone?
Great question. Thank you for that. Yeah. So no. Other companies are capturing carbon, but we just don't make the carbon, right? So and the key is we use a different rock. So if you use limestone, the limestone decomposes into CO2 and lime. If you use a calcium silicate, which is what we do, there's no CO2 in the rock whatsoever.
So how the heck did you get into this? This is heady chemistry, right?
Yeah, it is. So I got an undergraduate degree in chemistry, and then I went and got a PhD in environmental science and engineering, and where I went, Caltech, where I went to graduate school. That can mean a lot of things, and what happened to me at Caltech was, for me, chemistry. So
Uh-huh.
I was working on various industrial processes. First, making chlorine gas, which is what bleach is ultimately, and then sulfuric acid and oxygen and hydrogen and a few other industrial chemicals. And the reason I was working on industrial processes is because I wanted to work on something that was a big consumer of energy and was a big environmental problem, but was not really worked on that much because I wanted to see if, as an individual, I could have, I could actually have an impact. Whereas, like, if I worked on something that was really commonly worked on, uh, it was unlikely that I, as an individual, would be able to have an impact. So, so I started out with, I guess, really working on chlorine gas to try to make bleach to try to treat wastewater for applications in low income countries. And I thought about starting a business with that technology, but I did an economic analysis and I found that it really, the technology I was working was really, really bad. And what I was, going to do was try to sell wastewater treatment at a much higher price than we pay in the United States to folks in low income countries. And that seemed like a um, pretty poor way to try to solve the
To help.
problem. Yeah, exactly. So I went back to the drawing board and I sort of went to some talks, and one of the talks that I went to at Caltech was from this guy named Dave Danielson, who is the managing director of a group called Breakthrough Energy, or Breakthrough Energy Ventures, which is sort of Bill Gates' is effort to invest in companies to stop climate change. And one of the things that Dave Danielson said was that cement is a huge emitter and no one cares about it. And I was like, that sounds like something I could care about. And sort of went back to the drawing board and looked at some techno-economics and tried to see if I could make the economic problem work and also the carbon problem work. And I thought that I could, so I started this. So I started this company with my co-founder Hugo, who is also at Caltech, and we worked on it for a while. And then we were very lucky to meet another person from Breakthrough Energy Ventures named Cooper Rinsler, who's been sort of instrumental in this. And we and ultimately we figured out a process that we think will work, and we haven't been seen any evidence to think that it won't work at this point, and that's why we're still going.
And who's paying for this? I mean, I'm sure this research is very expensive and requires very special equipment. Am I right?
That's correct. Yeah. So certainly a lot more money than I've ever had. Um, so we've been very lucky. So we first at first it was paid for primarily by the Department of Energy through an amazing program called Cyclotron Road,
Mm.
which is this program that's at the time was run out of Lawrence Berkeley National Lab, but now is spread and is run out of lots of locations. And we got some money and some lab space at Lawrence Berkeley National Lab where they already had where taxpayer dollars had already paid for all of this analysis equipment that we could use. So I guess we all are paying for it, so thank you very much for that. And
Yeah.
then after that, we got the technology to a point where it looked like it had a bigger chance of working, so we approached several venture capitalists, and uh, and we were able to sell some of our company in exchange for liquidity,
Yeah.
some more money, and now it's primary venture capitalists who are paying for it, including Breakthrough Energy Ventures, which I have already mentioned, as well as DCVC and the Collaborative Fund and a few others that these were never household names to me. I don't imagine they're household names
Yeah.
to most people.
It's part of the problem is how important concrete is to modern life, both in developing and developed nations, right? Like, how much concrete are we using in volume? You mentioned some of the emissions, but like, I think people would have a better perspective of what we're talking about if we talk about how many yards of concrete as an example.
Yeah, so I always think in tons, and so I think I always forget the conversion off the top of my head, but I think a yard of concrete is approximately a ton, and maybe it's a half a ton or 2 tons. I can't quite remember. Um, but let's start with cement because that's what we make. So worldwide we use 4 or 5 billion with a B tons of cement every year, and then Cement is about 10% of concrete. So we use 40 to 50 billion with a B tons of tons of concrete every year globally. And that makes it the most consumed human-made material on the planet. So by mass, right, by just quantity of material, we use more concrete than we do coal or oil or gasoline or and the only thing, in fact, that we use more of is water. And that's no one says that's human made.
And
So
the planet has three-quarters of is three-quarters of water, right?
that's right. Yeah,
Yeah.
exactly. So it's an enormous thing, and it's actually, we use quite a bit in the United States. We use somewhere around 100 million tons per year in the United States, but mostly cement is used by rapidly developing countries because they are building cities that the United States already built back in the
And
day.
highways
Yeah,
and power plants and all these things, everything.
everything exactly. Yeah, and
So
that's
I'm
where we expect
guessing
it to be. Yeah, please
I'm
start.
guessing your goal is not to go into the concrete business. My guess is you're hoping to get this technology out there that current Portland cement producers will adopt. Is that a fair characterization of the company's goals?
Yes, that is fair. What my goal is to try to decarbonize cement as fast as possible. So there's sort of you know a push and pull there, I guess, or a little bit of tug of war. So we want to make sure that this technology could be adopted everywhere, and if we were to exclusively license it to one cement company that primarily worked in one region, then probably we wouldn't be able to globally decarbonize cement. Um, so we want to make sure that we can license this to everybody, and exactly how we do that, we're not sure. But I think it is the most efficient thing to be able to license our technology to all the existing players, since they have all the customers and the brands that people know and everything like that.
You make the distinction of eliminating carbon from the production of Portland cement. What about the rest of the process? Like, getting aggregates, and there's a lot of water that goes into concrete, and then you got to get it to the site, and then and it's going to be in a diesel truck. And, is that part of the hope too? Can you solve that part?
We can't, but we would love for that to be solved. So the good news is, though, that the production of Portland cement is responsible for 90% of the emissions of even the concrete. So compared to the energy and especially the process emissions, right? That's the CO2 from the limestone. The emissions from burning diesel to quarry and to transport and everything is actually fairly minuscule. But there's a lot of great companies who are working on those problems, and they're really clean fueling problems. So of course the ones that we've heard of, like Rivian or Tesla, that are making electric cars, but there's also folks that are making electric
Big trucks.
fuels, like big trucks, exactly. So like hydrogen and ammonia. So like electric hydrogen, for example, is a company that works on that. And there's so hopefully other companies will solve those problems, but the biggest chunk from concrete is cement production.
We'll be back with more right after this. Regular listeners to the Fine Homebuilding podcast have heard us mention Zip System Building Enclosures, the integrated sheathing and sealing solution system providing a streamlined approach to exterior water, air, and thermal management. But they may not be aware of the multiple resources available to builders with application or installation questions. Huberwood.com has the install detail library and access to the technical information team. How-to information is also available on the Zip System YouTube channel and on Instagram and TikTok by following @HuberWood. I don't suppose you've been to the World of Concrete. It's the trade show dedicated. Have you been?
I have not. I've
Oh my God!
almost
So
went
you
this
got to
year.
go for starters, but it's a big deal. I've gone once, and it was jaw dropping, overwhelming how enormous it is. It reinforces how big the concrete business is. And I'm guessing, like any big business, there are entrenched players who have a stake in, making Portland cement the way they always have. Do you feel like you can help the industry respond like the way they need to for all of our benefit?
I hope so. So I hopefully I'll see folks of the World of Concrete next year. That's our sort of our tentative plan to maybe go next year. I've watched the video. It looks like a wild time in Vegas.
It's super cool.
Yeah, yeah, um, and yeah, just amazing things on display and that sort of thing. So what we see is it's I kind of take a sigh because this is like probably the biggest challenge. If we actually can build the technology, this is the biggest challenge. So we need to transition to zero carbon really fast. And when I say really fast, I mean 20 to 80 years from now. And that truly is really, really, really fast. So to put that in perspective, there's two processes right now basically to make cement. There's the dry process and the wet process. And the dry process is like 25% cheaper than the wet process. And it was invented about 80 years ago. And still we're at like only 80% of cement plants use the dry process and 20 use the wet process. So it's we need to have a pretty fast transition compared to what we've seen in the past. And when you look at other industrial processes, I've only ever seen fast transition happen when
there's an economic
exactly when the way to make the thing
right?
exactly when the way to make the thing is lower cost. And based on our current technical milestones that we've hit and our current techno-economics, we are making a substantially lower cost way to make cement
Than current methods, really?
That's right. Yeah. And we'll see as engineering progresses, and we'll see how that comes out in the end. But if we are successful, I will measure success by our ability to go to the big players, the CRHs and Cemexes and Wholesomes of the world, and say, hey, we've got this awesome new process to make cement, and it can save you money, can save your customers money, and guess what? It's zero carbon.
Mm-hmm.
So let's make cement this way, and hopefully that will be a no-brainer for folks. But we will have more certainty on that as the technology progresses. I don't want to imply to you that we've already solved all the problems.
How long do you think it could take before you have a commercially viable process with a carbon neutral, carbon-free Portland production?
Yeah, so we're building up. We're starting basic engineering on a pilot plant right now.
And where is that located? I'm sorry to interrupt you, but I'm dying to know.
Yeah, absolutely. So we actually have not closed on the land yet. So we are near certain where it's going to be located, but I don't want to say in case
Sure. Yeah, because you stymie the real estate deal if you blow the cover, right?
That's right. But I will, as soon as we close on the real estate, I'll send you an email.
All right, man.
Excuse me. But so we will have some capacity, maybe 1,000 tons per year, hopefully starting in sometime in 2023, and then we'll hopefully have if the pilot plant goes well, we ought to be able to start building our the first actual industrial scale plant, which will sort of finally de-risk the engineering sometime in 2025. So we could have hundreds of thousand or 100,000 ton capacity or something like that in 2025, 2026. And then after that, it sort of depends on, our partners and joint ventures and how fast we can get things out. But I'm hoping to, have a pilot project going with our cement in 2023, and then actually start building buildings in 2025, 2026.
I suspect you heard along with the rest of us about, the timeline that we thought we had for dealing with this stuff is shorter than we had hoped to even keep climate change below, 2 degrees Celsius. To me, this can feel very overwhelming, and I'm sure I'm older than you. And, with youth comes optimism, and you have a stake in this, of course. Do you have the same feelings I do that this is an overwhelming problem? And your company is doing important work, but it's only a percentage of the bigger problem.
Yes, it's very
So if
grave.
that didn't make you depressed,
Yeah, no, absolutely. It's an overwhelming problem. It feels overwhelming for me every day. But how I sort of think about it is there's lots of problems in our world. Poverty, racism, all it is,
water, yeah,
water.
pick it,
Yeah,
yeah.
exactly. Yeah, pick any. Um, there are an enormous amount of problems in our world, and they're all feel overwhelming to me. But just because they're overwhelming doesn't mean we shouldn't try. And the thing with climate change is, okay, it's not like the Earth is going to, like, if we don't hit our 1.9 degrees C or 2 degrees C target, which I think we have to totally decarbonize in about 20 years in order to do that, which is seems impossible. um, uh, then like it's not still good to decarbonize, right? So it's always, the more the Earth warms, which is related to the concentration of CO2 in the atmosphere. So how long we start net producing instead of net being net neutral or net drawdown, is related to how sort of, for lack of a better word, catastrophic warming will be. So even if we miss the 20-year target, the 40-year target or the 60-year target is still important, and the 80-year target is still important, and all of these things are still very important. So I think what motivates me is, like, I don't think that the best possible outcome is within grasp. I really hope it is, and we're going to work as hard as we can to get there. But realistically, I agree it's not there. But I think that avoiding the worst possible outcome is
it's
within
worth
our
doing.
grasp,
Yeah.
and it's worth working on.
So do you have a concrete house?
Yeah, I do. Yeah, I mean, it's the foundation is concrete anyway. It's mostly wood, but yeah.
So most of the folks who've been on this show, and we've had all kinds of different people on here, but most have been tradespeople, and they like to work on their house, or they don't in their off time. Do you like to work on your place?
I don't. I found I do a lot of engineering at work. I find it when I go home. No, I don't want to do more of that. And I think that I am incredibly unskilled, compared to, so actually, and these days I actually take a step back from most of the engineering and lab work. Like, I'm incredibly unskilled compared to our amazing employees that we've hired, that sort of thing. So
Sure.
yeah, I think the most recent, I mean, like, the most recent thing I did is I installed a spice rack.
That's what's so great about the different people we have on the show, is like all different interests and skill levels, and yeah.
Yeah.
I think the work you're doing is super important, and I wish you great success. And it's been a pleasure talking to you. Is there anything you want to ask or tell our listeners before we go?
Yeah, so a couple things. Yeah, and thanks for asking, Patrick. So first of all is we need we have two asks here at Brimstone. So the first is, we're building a pilot plant, and we need folks that are really skilled engineers and tradespeople and good at building things to come and help us build our pilot plant. So you can go to www.brimstone.energy, and you can go to our careers page, and we would love for y'all to come work with us. And if you see anything in particular, if you think your skills could be valuable and the job isn't there, you can reach out to me or the company directly at info@brimstone.energy, and we'd love to see your resume. And we'd love some of the folks on this podcast to come work for us. And then the second part is, if you have a pilot, if you want to use some of our cement, and we're super excited about getting it out there. So we're going to have some available in 2023. So please, send me an email with your project idea, and we'd be happy to consider it. And again,
just to be clear, so you're going to like put your Portland in bags and give it out to people with small projects to mix their own concrete. Is that right?
So we can't do that infinitely, right? But yes,
sure, that'd be crazy. But yeah.
Yeah, absolutely. We're hoping to have a few select pilot projects that we think would be really interesting. So I'd love to hear about people's pilot projects they're interested in. So please send me an email at info@brimstone.energy.
Please do that, listeners, because I
Yeah.
want to know about it myself. I think that's really cool.
Yeah. Thanks, Patrick. Appreciate it.
So
Thanks
how
so
can
much for
people
having me on.
in other ways support the company mission?
Yeah, so I think big piece is education. So thanks for listening to this podcast. Like, a lot of people don't realize that cement is so CO2 intensive. So tell your friends to listen to the podcast, or Google it and find an article, and educate your friends. And I think that's like one of the big ways that we get policy to support us and everything else. So yeah, education.
Well, it's been great having you on the show, Cody Finke. Thank you.
Yeah, thanks, Patrick. I appreciate it.
Well, unfortunately, that is all the time we have for today. Thanks to Cody Finke for joining us, and thanks to all of you for listening. Please remember to send us your comments, questions, and suggestions to fhbpodcast@taunton.com. And please like, comment, or review us however you're listening. It helps other folks find our podcast. Stay safe, everybody. Keep craft alive. And pay attention to Cody and Brimstone Energy.